Good morning. Today we will discuss new topic, new practical about chromatography. Clear? Now look here. Uh, what is chromatography? So it is a technique for separation of components, of a mixture and purification of compounds. This is chromatography. It is based on differential migration of the various components of a mixture through a stationary phase under the influence of a moving phase. So this is your basic chromatography definition. Okay, I will repeat second time. Look, it is a technique, one type of technique. Okay, chromatography is a technique for separation of component of a mixture. Okay, and purification of compounds. So it is a one type of method, chromatography. Clear? And it is a base of differential migration of the various components of a mixture through a stationary phase under the influence of a moving phase. Okay. Now in chromatography there are many parts. For example, paper chromatography, then column chromatography, then thin layer chromatography, gas chromatography. Okay. So today we will discuss about paper chromatography. Okay. Marigold solution and second one spinous solution. Okay. Now next topic is RF value, retention factor. Okay, RF. So RF value is equal to distance traveled by the solute, okay, from the original line. So I will discuss about original line divided by distance traveled by the solvent, okay, from the original line or reference line. Okay, so here your RF value, distance traveled by the solute from the original line divided by distance traveled the solvent from the original line. So here is your chromatography, okay, example of chromatography and RF value. Clear? Here is a figure, okay. So here is your beaker or jar. Here is your methanol solvent, methanol or ethanol, alcoholic solvent is here. Okay, here is your glass rod, and you have to take Botman filter paper. Okay, you have to use Botman filter paper in chromatography. Okay, so here is your chromatography paper. Clear? Now look here, chromatography paper. Now you have to take 3 centimeter upper side and you have to sleeping line here, okay, and put a spot here, dot here with the help of pencil. Okay, now look here. So here is your original line, okay, or reference line, original line or reference line. Okay, now look here. Here is your pure solvent, methanol or ethanol. Clear? Now you have to use marigold solution or spinous solution. Okay, so we are using here marigold solution RF value and spinous RF value. Okay, now look here, you have to put a dot of solution of marigold in middle side. Okay, and in case of spinous solution, follow same rules. Okay, put a solution of spinous solution in a middle dot. Okay, so here is a one type of method of paper chromatography. And look here, what happens? Solvent is rise. Here is the area of solvent. Okay, and here is the area of solute traveled distance. Okay, here is your solute traveled distance and here is your solvent front. here to here, solvent front. Okay, so we will perform now practically. Now listen, here is your marigold solution. Here is your marigold solution and here is your spinous solution. Okay, spinous and marigold. Okay, now here is, we are using here titer tube, and in titer tube here is your solvent methanol or ethanol. Okay, now look here, here is your Wattman filter paper we are using here. Okay, now first of all we have to measure 3 centimeter. We have to measure 3 centimeter in lower side. Okay, and put a sleeping line. Like this way. Look, like this way. Clear? 3 centimeter. Okay. Now look, in the middle side put a spot or dot in middle. Okay. So look, I am making a dot in between, okay, of sleeping line. So here is your dot or spot, okay, in middle. Okay, now I will put a spot or dot of spinous and marigold in middle of spot. Here is marigold. So here is spinach, okay, spinach, and we put into our titer tube lower end, okay, deep in the solvent. So solvent will rise up. Here is marigold, here is spinach. So this is your procedure. After some times I will show you. Now listen. After some times, okay, the solvent is rise up. Now here is your original dot, okay, and this is your marigold, okay. So underline solvent here. Here is the centimeter of solvent and here is the centimeter of solute, okay. So in marigold, here is your solute and here to here is your solvent, okay, centimeter. Now look here, in marigold, distance traveled by solute, okay, distance traveled by solute is 2.2 centimeter here. 2.2 centimeter, okay, and distance traveled by solvent means here to here, solvent is 5.3 centimeter in marigold. Okay, solute distance is 2.2 centimeter here to here. Okay, here is your yellow line, yellow. Okay, yellow space. So 2.2, and here is your 5.3 centimeter. 5.3 centimeter solvent and 2.2 centimeter is for marigold solute. Okay, now in second stage, so here is your spinach. Okay, so in case of, here is your second spinach, so green dot. Okay, now distance traveled by solute means here to here is 1.5 centimeter, here to here. Okay, from dot side to here, dot side to here. Okay, 1.5 centimeter only, and solvent distance is 5.5, means here to here. Okay, solvent 5.5 and 1.5 solute distance. Clear? Now RF value. So in marigold 2.2, distance traveled by the solute 2.2, okay, and distance traveled by the solvent 5.3. Okay, it means your marigold's RF value is 0.41 nearly. Okay, and in case of spinach, so distance traveled by solute is 1.5. Okay, and distance traveled by solvent, okay, is a 5.5 centimeter. Okay, you have to measure distance traveled by solute, okay, in yellow color, in marigold, and in spinach green color. Okay, in spinach you will find green color. Okay, so spinach 1.5 centimeter solute distance and 5.5 centimeter solvent distance. Lastly, your figure of RF value in spinach is 0.27 or nearly. Clear? So this type of practical we have performed here in chromatography, paper chromatography. Thank you.